Here we have a maglev train, that stands for magnetic levitation, on the Yamanashi test track. And we're going to learn how we can describe its motion as it moves along a straight line there. Now, the actual behavior of the train is a little bit more complicated. For example, there's that magnetic levitation stuff, but the techniques we're going to learn are going to still be applicable to describing the motion of even sometimes complicated systems. We'll start by defining position, displacement, and velocity, and then move into calculating instantaneous velocities. And then we'll look at accelerations, which are the change in velocity, and look at some special cases of constant acceleration and free fall. We'll end with being able to work our way backwards from acceleration into finding velocities and displacements. So first, what does kinematics mean? Well, it's the description of motion without considering its causes. So we're not caring about why things are moving. We're just looking at if things are moving, how does that motion behave? Spoiler, things are going to move because forces are applied to them, but that'll come later. So we need position, where something is. Generally, we'll use meters to talk about these as the unit, but this is going to be a dimension of length. So position, where something is. In order to define this, it's most convenient to define a frame of reference, which is a set of axes. It says arbitrary here. That means we get to choose our set of axes that we want to describe this. And in general, this will be defining an origin and then the direction the axes are going. So here you have an x-axis. You might have a y-axis coming up normal to that at a 90-degree angle, and maybe a z-axis. Here, since we're doing straight line motion, we're going to be focusing on just x-axis, one directional motion. So now with position, we can define a quantity called displacement. And displacement is a change in the position of an object. This is a vector quantity, which means it has a magnitude and a direction. So our displacement is defined as my final position minus my initial position. So again, we have our axes here. We have an x, y axis, and we look at our initial position of 1.5 meters, our final position of 3.5 meters as we walk to the other side of this whiteboard. We have then a displacement of my final 3.5 minus my initial 1.5 to give me a total displacement of a positive 2. And the direction is in the positive x direction. So its magnitude is 2 meters. The direction is in the positive x direction. So final position, initial position, and total displacement is then the summation of any displacements you want to consider. So all this says here is that if we have multiple other displacements that we're considering, we can just add those up. So this would be like my displacement 1 plus my displacement 2 plus whatever other displacements we have, we can just add those up. So this sigma is a summation symbol, just meaning add up whatever other displacements. For example, if we have a bike traveling here, we start off by traveling 3 kilometers to the west, and then we turn around and bike 2 kilometers back east. So what is the distance traveled by the cyclist? Well, the distance traveled by the cyclist is you just add up the magnitudes of these and say, well, we traveled 3 kilometers, then we traveled 2 kilometers. So the total distance is equal to 3 kilometers plus 2 kilometers for a total of 5 kilometers total distance traveled. But what about the displacement? Well, the displacement is a magnitude and direction, and it cares about initial minus final. So here, if I have this as my positive x direction, the displacement says that I can add up this initial displacement, which was 3 kilometers in the negative x direction, or a displacement of negative 3 kilometers. Plus then we have the 2 kilometers in the positive x direction, so plus 2 kilometers gives me a total displacement here of negative 1 kilometer. So that's 1 kilometers in the negative x direction, or I might write that as 1 kilometers west. And that's position and displacement.